All right, welcome to section 6.3, exponential functions. So what is an exponential function? So it's a function, so I write f of x is equal to 2 to the x. So the variable is in the exponent position. So the variable's in the exponent position. We're going to come up with a table of values here. So 0, so 2 to the 0 power, of course, is 1. 2 to the first power is 2. 2 to the second power is 4. Putting in 3 to the third power is 8. So this grows really fast. So hence the expression, oh, that's growing exponentially. Like it's going up really fast. Negative exponents. So negative exponents become fractions. So if I put in -1, that's 2 to the -1, which is 1 over 2. Cross the line, change the sign. If I do -2, it'd be 2 to the -2, which is 1 over 2 squared, or 1/4. And if I do -3, that'd be 2 to the -3, which is 1 over 2 to the third, which is 1/8. 2 times 2 times 2. So notice the 3 and -3 make 8 and 1/8. The 2 and -2 make 4 and 1/4. And the 1 and -1 make 2 and 1/2. And then 0 is like the center. So here's the graph of this. So 0, 1, we'll call that 0, 1. And then 1 over down 1/2. And then another 1 over and down 1/4 and 1/8. So this gets really small when you go this direction, but it never crosses the 0. And then when we go this direction, it becomes really large. Okay, and I didn't mark it off very well. I just did your basic, your basic curve. So we're going to talk about all the different manipulations of this. I'm going to get out my graphing calculator. I'm going to type in 2 to the power, with the little exponent thing there, x. Alright, now I'm going to manipulate this. What would this look like if I did a negative in front? Negative x to the power of x. So I'm doing a negative in front. What's that do to it? So think about what it does. Now let's see what it does. I'm going to do zoom and standard. Number 6. Are you thinking about what it does? So there's the regular graph. And the negative in front does what? Oh yeah, it flips it over the x-axis. So let's go ahead and zoom in here a little bit closer. Alright, now let's manipulate it again. So I'm going to get rid of this negative in the front, and I'm going to put the negative up here. So I'm going to second insert negative. So you can see I put a little negative in there. Okay, what's that going to do? How's that going to flip it? And I had to pause the video for a second. And you can see when you do that, it flips it over the y-axis when you replace x with -x. And we did those before with other functions. It's just now we're doing with exponential. Alright, so those are done. Kill the negative there. What if I did a +3? You should know what that does. That's going to move it. How? Well, let's see. There's the regular function, and it moves it just like you thought, up 3 spaces. So now the question is, how do I move it to the left and the right? Well, you have to change x first. So I'm going to go to the y equals again. I want to move it 3 spaces to the right. So I'm going to go, whoops, go right in here. and then do minus 3. That would be 3 spaces to the right. Delete, delete. Remember, the negative moves it to the right and the positive moves it to the left when it's affecting the x first in the order of operations. So we hit the graph, and it should be 3 spaces to the right. And there it is. It's shoved over to the right. Now, don't let things confuse you here. If I wrote this down, 3 minus 2 to the x, that's the same thing as negative 2 to the x plus 3. Okay, so if it's the minus was with there either way, so it flips it upside down, and then that means up 3, flips it upside down, up 3. So these mean the same thing. You just have to think about, the order of operations. So that's important first, and then the 3 moves it up 3. This happens first, and then the 3 moves it up 3. So either way. So now you're prepared to do some matching problems in the book on page 435. So I have some matching problems I want you to do. Okay, now for solving equations. Example 1. We are going to solve, how about this one? 5x plus 3 is equal to 1/5. So what we want to do is be able to see it, so I need to move the paper here. Alright. And refocus. Okay, here we go. So what I want to do is I want to make these be the same base. So there's different rules of exponents. The main rules of exponents are when you multiply like bases, you add the exponents, right? When you have division, you subtract the exponents. When you have a power raised to a power, you multiply the exponents. When you have a negative exponent, it means fraction. And anything to the 0 power is 1. Those are the rules of exponents, the basic rules of exponents. So negative exponent means fraction. Anything to the 0 power is 1, except for 0. 0 to the 0 power is obviously undefined. And then these rules here. So we're going to apply this to this. So basically we want to make the bases the same. So this can be made the same base if I do this. So 5x plus 3 is equal to 5 to the negative 1. So 5 to the negative 1 is the same thing as 1/5. You cross the fraction line, change the sign. So now, since the bases are the same, the exponents have to be the same. So x plus 3 equals negative 1. Subtract the 3 over, x equals negative 4. All right. Let's do another couple examples here. Example 2. Here's a fun one. 9 negative x plus 15 and 27 to the x power. So to me, I recognize 9 is a couple 3's multiplied together, and 27 is some 3's multiplied together. So what you can do is you can make this 3 squared, and then to the power of negative x plus 15. And then you can make this one 3 cubed to the power of x. So what do we do over here? When you have an exponent raised to an exponent, you multiply the exponents. So that's what we're going to do now. We're going to multiply these exponents. So we're going to do 2 times this exponent. So it's going to be 3. And then 2 times that would be negative 2x. And then 2 times the 15 is 30. And then 3 times x is 3x. So it's 3 to the 3x. Now, since the bases are the same, the exponents have to be the same. So it's 3x is equal to negative 2x plus 30. Add over So we get 5x is equal to 30, divide, x is equal to 6. So x is 6 on that one. And if you're unsure, put 6 back in. 27 to the 6th power, and then 9 to the 9th power. Yeah. So what this is saying is 9 to the 9th power is the same thing as 27 to the 6th power. That's what this is saying. Because if I put 6 back there and add those together, I get 9. If I put 6 there, it's that. So you can type that in the calculator and prove that those are actually the same. So there's example 2. Let's see. What else could we do with this? Let me pause it for a second. All right, so here's example 3. So we got e to the 4th. E is the Euler number, 2.718 and change, to the x power times e to the x squared is equal to e to the 12th power. All right, so when you have a power to a power, you multiply, right? Multiply, so it's e to the 4x times e to the x squared is equal to e to the 12th power. When you multiply like bases, you add the exponents. So it's going to be e to the x squared plus 4x. Then we know the exponents are now the same. So x squared plus 4x is equal to 12. X squared plus 4x minus 12 is equal to 0. So that's the old deal with the what do I say? Quadratic formula or factoring. This one factors. So it's going to be plus 6 and minus 2. That would be correct. So x is equal to negative 6, x is equal to 2. All right, so that's the answers with those. That all checks out. And then example 4. If 2 to the x is equal to 3, then what does x to the negative, 4 to the negative x equal? What does that equal? All right. So we need to make this look like this over here. Well, 2 is squared, and that would be times negative x. Let me rewrite that. So 2 squared to the power of negative x. There we go. These are the same. So now I'm going to multiply. When you have a power to a power, you multiply the exponents. So that's going to be 2 to the x, and then I'm going to leave the negative there and do that. So this times this is equal to this times this, because this times this is negative 2x, and this times this is also negative 2x. But now look, I can substitute. I can put this 3 in here. So now I can say that it's going to be 3 to the negative 2 power, because this is equal to 3. So I get squared and then flip it upside down, answer 1/9. So the answer to this is 1/9. So that's kind of a clever problem. So basically you need to make this be the same as that. All right, that's the deal.